So we discussed about two main basic set operation: set intersection and set union. So who is this Alex? Alex? So the next operation is what we call set difference. Let A and B be two sets. Then the set difference or sometimes we call relative complement of A with respect to B denoted by A minus B is defined as A minus B is a set of all elements X such that X belongs to A and X do not belong to B. That is to mean set of all elements belonging to set A but not so the set A minus B is a set that contains all the elements in set A, but excludes the elements which may be counted to be both in A and B. So if we were to represent this set in a Venn diagram, so this is a universal set. So if this set A then this set B A minus B is this set. So the shaded part is what defines the set A minus B, means that it is a set that contains all elements that are counted to be in set A, but removes all those elements which may be regarded or which can also be regarded to be in set B. So you are exclusively in A and not in B. So what we have here is A minus B. So similarly, we can define B minus A to be the set of all elements X such that X belongs to B and X do not belong to A. Elements of all elements that are counted to be in set B, but not in set A. And so if you represent this on a Venn diagram, so this is the inverse of set. If this set A, and then this set B, so we refer to this as a set B minus A. You must be exclusively counted to be in the set B. So another example now, if A is a set 1, 2, 3, 4, 5, 6, and B the set 0, 1, 3, 5, and 7, what is the set A minus B?
A minus B.
Will have which elements? Will have 2, 4, and 6, correct. So I mean that those are the only elements which can be counted to be in set A, but are not found in set B. So the elements 3, 1, and 5 are excluded because they are also part of this other set B. B minus A zero, 0 and 7. So those are the only elements which can be found in B, but not in A. Good. And what is A intersect B? One, three, and 5. Correct. What is A union B? One, one, two. Next. There's no problem. So A union B, just write what is everything that you are seeing in A. 1, 2, 3, 4, 5, 6, and then add those which are not which you have not counted in B. 0 and 7. Remember, order does not matter when you are putting those numbers. If you want, you can put it, but still there's no special, okay? So A union B simply means that write all the elements of A join to elements of B. But what you have already written, you don't repeat. So the next set operation is what we call symmetric difference. So let A and B be two sets. The symmetric difference of A and B denoted by or sometimes we write you write A, then small circle, and then you put plus in the small circle. B is defined as the symmetric difference of A and B is a set of all elements X such that X belongs to A or X belongs to B, but not both. So we mean that you are exclusively counted to be in A or in B, but you don't include a part which can be counted to be both in A and B at the same time. So if you are to put in a Venn diagram, so this is the universal set. If this set A and this set B, then what I'm going to share is what defines the symmetric difference of A and B. So that is the set symmetric difference of A and B. That you are either in A or in B, but not both in A and B. So we are removing this intersection. And so remember the symmetric difference is also called the Boolean sum of the two sets. So if someone asks you, how can you relate the union of A and B and symmetric difference of A and B? What's the difference? What's the difference between the union of A and B and the symmetric difference? Are there symmetric difference? Okay, so we are in simple terms, we are simply removing the intersection. So I should say that A symmetric difference with B is nothing but A union B minus A intersect B. And then also is the same thing as saying A minus B union B minus A. So if someone asks you, find the symmetric difference of A and B given A is 1, 2, 3, 4, 5, 6, 7, and B is 0, 2, 4, 6, 8. Then A minus B will be given by one, 3, 5, and 7. And b minus a, 0. Kevin, what is b minus a? 0. Next. 0 and 8. Okay. So then now the symmetric difference of a and b is a minus b union b minus a. So which will be given by 1, 3, 5, 7, 0, and 8. And check that what will be the A union B? Zero, 0, 1, 2, 3, 4, 5, 6, 7, and 8. And what is A intersect B? Two, 4, and 6. Then what is A union B minus A intersect B? Means those elements which are in this set, but not in this other set. 0, 1. Those are the only ones. And 8. And you should see that this set and this set are just the same. So you can either remember this 1, 2, 3, 4, 5, 6. This 1, 2, 3, 4, 5, 6, and they're the same. Either you can define the symmetric difference using the union of A minus B and B minus A, or you can define it using the difference between A union B and A intersect B. So whichever approach you take, we will always arrive at the same answer. And the two approaches actually are very clearly from the Venn diagram representing the symmetric difference of A and B. Okay? Yeah. Then next one is what we call Cartesian product. Cartesian product. Let A and B be two sets. The Cartesian product of A and B denoted by is defined as A cross B is a set of all ordered pairs A comma B such that A is from set A and B is from set B. And please mind your notation that the pairs we are putting in these curved brackets, but these other brackets for sets remain to be curly. Okay? Yeah. Similarly, B cross A will be the set of all ordered pairs B comma A such that B is from B and A is from A. More generally, the Cartesian product of n sets A1, A2, A3, all the way up to AN is defined as A1 cross A2 cross A3 cross up to cross AN and is given by A1 comma A2 comma A3 up to comma AN such that AI is from AI for I equals to 1, 2, 3, up to N. The expression please note that as I told you from the start, these things are very sensitive to the notation. So don't replace this curved brackets with curly brackets. We'll be actually having a different interpretation. It's called an ordered n tuple. Catherine, how are you? Katia, how are you? Okay. Fine. Where is Kevin? Okay. Fine, fine. So you need not to worry. So we had the first class last week and it was recorded. So I'll share the link so that you follow up to connect that. Good. So then let's make example. So given that A is A, B, C, and B is 1, 2, find the Cartesian product of A and B, and then Cartesian product of B and A. So this is how you work it out. Remember, order matters. So which means that we'll have pairs such that in each pair, the first number comes from set A when we are defining A plus B, and the second number comes from set B. So we'll have A, comma 1. So this A you pair with 1. Then same A, pair with 2. Then you go to B. B, you pair with 1. Then same B, pair with 2. Then C, you pair with 1. And lastly, C, you pair with 2. So that will be the complete set. That A cross B means that you are going to get elements which are in form of pairs, such that the first element, the first number in each pair comes from set A, and the second number in each pair comes from set B. So B cross A, what would be the first element? Following that same procedure. One comma A, followed by 1B, followed by 1C. So we have paired 1 with all the elements of A. Next. Two A, 2B, and 2C, correct. So that is the set B cross A. And number 3, what is the cardinality of A cross B? How many elements are in A cross B? Or how many pairs are in A cross B? Six. So 1, 2, 3, 4, 5, 6. So the cardinality of A cross B is 6. And then cardinality of B cross A, still 6. Question 5 is A cross B equal to B cross A. Are they equal sets? What is the meaning of equal sets? Okay, good one. So if I write, you see, like this element here, A comma 1, and this other element here, 1 comma A. So you say they are the same. And if I write this, A comma 1, 1 comma A is equality true or false? Is equality true or is false? First one. First one. Yeah. So yeah, so this is not equal, but this is true. So remember, this is a set, this is a set, but these are points or pair. It's like asking you if you are to plot point 2, 3 in the Cartesian plane and point 3, 2. Are they at the same location? The answer is no. Okay. So you have, that's why I'm saying you have to be very careful on the notation on what you're writing, because careless use of brackets can lead to misleading information. So if you are writing set, if you write A comma 1, it will be the same thing as 1 comma A. But when you are writing pairs, like this one here, elements of the Cartesian product, then these are not the same. And so even that one alone now can tell you that you have to be very careful on which kind of brackets you are writing, because any kind of brackets you use has a different meaning with respect to the problem you're trying to deal with. So what is the answer to my question now? Is A cross B equal to B cross A? So the answer is no. So the elements of A cross B are not the same, not identical to elements of B cross A. But then we say A cross B is equivalent to B cross A, since equivalent sets are sets which have the same cardinality. Since cardinality of A cross B is equals to cardinality of B cross A. So the term equivalent and the term equal do not mean the same. Equal means same or identical elements in two sets. Equivalent means the two sets have same cardinality or same number of elements, okay? Yeah. So that should be clear. So the next definition is what we call power set. And we define power set of a set as the collection of all possible subsets that a set can have. So say let A be a set. The power set of A denoted by we note P of A is the set of all subsets of A. And should be noted that if cardinality of A is K, then cardinality of power set of A is given by 2 raised to power K. It's a very powerful formula that can be used to ask some problems involving the power of a set. So if you know the cardinality of the set, you can always give the cardinality of each power set by using the formula 2 raised to power K. Another note is that a set A is always a subset of itself. So any set is always a subset of itself. And the empty set is also a subset of any set. So these two are usually called the trivial subsets of a set A. So the empty set and the set A itself are called trivial subsets. The set A. So e.g., if A is a set with one element, A, 1, then power set of A will be this set. It will be a set having the empty set and another set with the element 1. If A is the empty set, then power set of A will just be if A is a set with elements A and B, then the power set will be first the empty set. Then you form subsets using one element each. And then you form the set using all the two elements, subset using all the two elements. So what would be the total number of elements in that set? So for this case, what is cardinality of power set of A? Four. So there are four elements. So 1, 2, 3, 4. Which we certainly expect because the cardinality of A itself is 2. So 2 power 2 is 4. If A has A, B, C, then so the power set of A will have these elements. One, the trivial, the empty set is always a subset of any given set. We start with that empty set. Empty set is a set with how many elements? What is the cardinality of empty set? 1. Cardinality of an empty set is cardinality of empty set is 0. So we'll have, so we start with that one. Then next, you form subsets with one element. You'll have A, you'll have B, you'll have C. Then you go to two elements at a time. So the first pair will be AB, AC, BC. Is there any other apart from these three? Because actually, if you change BA, you are defining the same set, so it will not be different from that, okay? And then finally, the whole set involving the three elements. If you count this, what would be the cardinality of power set of A? Eight, which should be what we expect, because we say that the cardinality of power set of A is the same as 2 raised power, the cardinality of A. So 2 power 3 is 8. So if A is having A, B, C, D, then what will be the cardinality of power set of A? Power 2 raised power 4 gives us 16, okay? Yeah. And if I ask you if cardinality of A is 6, then cardinality of power set of A will be 2 raised power 6. So what should be 64 parts. So that is how we deal with that kind of. So read and get more problems which can be asked around the same area. But those are few examples that can give you a start off. So an exercise one, state the laws of set theories. Number two, define the inclusion exclusion principle and explain how it can be used to solve counting problems on sets together with a Venn diagram or Venn diagrams. So here provide at least 5 examples. I'll provide enough material to make you do that work. There is no excuse. Even those who are physically in class, I gave it as an assignment or as an exercise. But there's enough. You know, the handouts and also previous class links to guide you. Next time we meet, we'll be discussing about logic. Okay? Yeah. So I'm stopping there for today.